Nuclear fuel and its enrichment. I've already referred to the fact that if we dig uranium out of the ground, only 0.7% of it is of the fissile variety. In 1940, Otto Frisch was working at Birmingham University in England with Rudolf Piles, another refugee from Europe and the Nazis. And very early in 1940, they came to the remarkable conclusion that it would be possible to build an atomic bomb using just a few kilograms of uranium-235. Hitherto, scientists had thought the job would be impossible because you would need many tons of uranium-235. 235 obviously exists in nature, but when only 0.7% of it is present in the ore, separating several tons of that from the 238 would be a very difficult task. Once they realised that it would only take a few kilos, then of course their interest sharpened. Their purpose was to warn Her Majesty's government, His Majesty's government, of the danger from the German threat, and similar people were talking to Roosevelt in the United States. So they turned their thoughts to how they might enrich uranium-235. In other words, take a sample of uranium and raise the proportion of 235 as against the 238. That's what the process of enrichment is called. If you want to make fuel for a power station, you need probably to enrich the 235 content to at least 3 or 4%. If you want to make weapons, then you want to go considerably higher than that, perhaps 20% or more. So this is a process of enrichment. How do we do it? Well, again, Piles and Frisch were very foresighted in that they came up with a method that the Americans eventually used in the Manhattan Project. And they figured that since 235 atoms contain fewer neutrons than 238 atoms, the 235 atoms would be slightly smaller than the 238 atoms. Only a small fraction, obviously, but it would be smaller. So they hit on the idea that if you took your uranium ore, UO2, U308, the ordinary dioxide and octoxide, you could dissolve it in hydrofluoric acid and produce uranium hexafluoride gas. If you then pass the gas through a permeable membrane, because the 235 isotopes were smaller than the 238 isotopes, the gas that passed through the membrane would be slightly enriched in favour of 235. And they figured that if you then took that sample and passed it through a second membrane, you'd enrich it a little bit more, do it a third time and a fourth time and a fifth time. Slowly, stage by stage, the fuel would be enriched in terms of uranium-235. They knew that it would take many, many stages, and initially it was thought that in this country, in the UK, the only company that would be possible of building such a plant to do this would be ICI. Eventually, this was done in the United States as part of the Manhattan Project. The Americans built what was at the time the largest building in the world at Oak Ridge in Tennessee to enrich uranium. And what they did was to link together at least 10,000 of these permeable membrane stages in series. So they needed a huge building where if you walk from the start of the process through to the end, you had to walk a mile. It was a huge building, the biggest in the world in 1942 or 3 when it was built. And this was the process that it used. It enriched uranium and stepped up the level of 235 in the metal to a point where it would be suitable for use in an atomic bomb. In an atomic bomb, you're not concerned with moderating the reaction and controlling its rate. You want it to go as quickly as you can, so a high level of enrichment is very desirable. So that's the process of enrichment and nuclear fuel. For power generation purposes, we don't need to enrich the fuel by quite so much, and we produce the fissile material in the form of pellets, which can then be sheathed in fuel cans, which can be made of things like zirconium and other materials. So I think sometimes they use stainless steel, but we can then put these fuel rods into a reactor. Of course, in a nuclear reactor, we don't want a runaway chain reaction like we do with a bomb. We want a controlled reaction. So it's very important we're able to control the speed of the neutrons, and it's very important we're able to control the rate at which fission occurs. So in a reactor we use moderators to control the speed of the neutrons, and control rods to shut the thing down or control the rate at which fission happens. So that's nuclear fuel. This is material which is fissile. For nuclear generation purposes at the moment, we tend to mainly use uranium, but we can also use plutonium, element number 94. This is a man-made element. It has 94 protons in the nucleus, and plutonium-239 is fissile. It was realized back in 1939-40 that plutonium would be fissile. The problem was to actually make enough of this material. And of course, again, the first plant to produce this stuff was built at Hanford in Washington State with the purpose of isolating and enriching enough plutonium-239 to make a nuclear weapon. Now, of course, we can employ the stuff to generate electricity. That's the principle behind nuclear power and its enrichment. We need to obtain enough fissile material to give us the fission rates and speeds that we need to generate either the explosion or the nuclear power.